A support chatbot serving 50,000 users gets asked, "What is your refund policy?" hundreds of times a day. Every call hits the LLM, pays the token cost, and waits a second or two. There are 3 catches that can collapse that to a microsecond and near zero cost. They work in completely different ways, and one of them can silently return a wrong answer if you misconfigure it. A cache sits between your app and the expensive operation. On a hit, return the stored result instantly. On a miss, do the real work, store it, return it. The whole art is choosing the key, and the number that decides everything is hit rate. Cache 1. Exact match. The key is a hash of the model, the parameters, and the exact input text and O of one lookup. Embeddings are the perfect candidate because an embedding model is deterministic, same text plus model, same vector, so you cache them indefinitely. But it is byte sensitive, a trailing space is a different key, paraphrases never hit. Cache 2, the semantic cache. Match by meaning, not bytes. You embed the query, find the nearest stored one, and if cosine similarity is above a threshold, return its answer. Now, how do I change my password? Catches the entry for reset my password. But here is the trap, the false hit. Set the threshold too low and a user asking, "Can I get a refund after 60 days? Hits the entry for, "What is your refund policy?" A confident answer that does not address their question, confidently wrong. So tune the threshold conservatively, 0.95 or higher, and scope the index per intent. Reserve semantic caching for stable factual Q&A, never for personalized answers. Cache 3. Provider-side prompt caching. Different in kind, it catches not the answer, but the computed KV state of a long, stable prefix. For a 10,000 token system, prompt those attention tensors are expensive and identical for every request reusing it. So the provider stores them and charges about 10% of the input price on a hit. To exploit it, put the stable part first, the user's message last, so only that small piece is recomputed. And the iron rule, keep the prefix byte stable, since any single character change invalidates the cache from that point on. And unlike the other two, prompt caching returns a fresh generation, so the answer is always correct. Now the genuinely hard part, the one the famous quote is about, there are only 2 hard things in computer science, cache invalidation and naming things. 3 failure modes. 1. Stale responses, so put the model name and version in the key. 3. And this has burned production systems, cross-user leakage. If your response is personalized, namespace the key by user or tenant. Serving user A's account details to user B is a silent data leak that tests won't catch. So the playbook. Exact match first, then semantic for the paraphrase tail, then provider prompt caching, nearly free. Version your keys, set your TTLs, namespace by user. And never forget the one trap that turns a cache into a liability.